Okay, so today I'm going to show you how to make a couple of simple stock flow shots. We're going to use a test reaction, DCAP mixing with ascorbic acid. We're basically going to observe the disappearance of the blue color at 600 nanometers. It's an absorbance reaction, and we're going to use this stop flow device to observe it. So let me first go through the steps of checking whether the instrument is set up correctly for the experiment and starting it up. The first thing that you want to do when you before you start the instrument is to make sure that you have the slits that you want. So currently I have 0.6 millimeter slits in all positions, so entrance, exit, intermediate slits is also 0.6. This is housed, of course, in this cartridge. Make sure that double check the slits are really in the proper orientation with a notch down, and they are inserted all the way in on all three positions. Put back the cartridge. You might want to check also the gratings, exactly what type of gratings you have, because the software needs to know what type of gratings you have in the monochromator. So there is just two lids on the top of the monochromator, and here the gratings are 400 millimeters lines per millimeters. This is the important number actually the software needs to know. The second number is the blaze wavelength, which the software does not really care about.
So your first is here and your second is here.
The second is here. The important thing, of course, is the orientation. Don't put them like that. Make sure that they're oriented proper so the reflective surface goes in this. The light has to hit the reflective surface. That's, of course, has to be the case. You can actually, maybe just to show you how this works, maybe I can keep this open for the time being and start the lamp so you're going to see the light inside. That's basically just a basic check whether you have the gratings in position properly, whether they're clicked, they're sitting properly in their slots, the positions of the slits are also okay. So everything's off, we go ahead and turn on the lamp. Press power and then ignite. The light is on. This is 75 watt lamp, currently 65. Over the next couple of minutes it's going to rise to 75 or close, so we're just going to let it warm up. Now if you look inside, you can maybe show here the first grating. The white light is hitting the first grating.
White light hitting the first grating.
Right here.
And by the time it comes here,
and then actually maybe while it's open you can show on the other side the spectrum and how how the slits. So this is the spectrum, and of course only one of these colors is going to pass through. There is the intermediate slit. This color of course proceeds to the second grating, and currently this is, if you look at it, it's kind of orange.
Orange, yeah.
So this is about 600 nanometers light, monochromatic light. I'm just going to close, so everything looks okay. You might want to check if you get light all the way through to the stop flow. One way to check that is the easiest probably just to open one of the ports and just look inside, and
you can see we're getting light.
You can see that we're getting light. Of course, now this is it's a visible wavelength. It's about 600 nanometers, but this is depending on what your monochromator was parked at the last time you turned off the instrument. So you might, if you park at something that is not visible, you're not going to see anything. So, but that's not a reason to worry. You can always put the monochromator on some visible wavelength and see where that's.
And you just turn on the master control box.
I just
right?
turned on the master control box and the computer. Now, before I proceed and explain the stop flow, let me just show you remind you where the monochromator wavelength can be changed.